So we didn't do anything deep last time. We talked a little bit about intervals. We talked about them in the context of like solving inequalities, the solution to an inequality will be an interval. I'm going to carry on the vein of things which hopefully will feel very much like review. But it's ideas that we'll use an awful lot, so I think it's worth repeating right now at the beginning. So we talked about intervals, and maybe let's start with this. If I ask you for the interval from 2 to 4, right? It's like there's 2, there's 4. I want things in between. For that interval, as I've notated it right there, does that include 2? No. Parentheses means exclude. And we indicate that via open circles. What if, though, I want to change it and replace that open circle with a bracket? How would that change what interval that means? Includes 4. Oh. It comes to mind that the following would be a reasonable thing to do. Anyone need a copy of this? Yeah. Cool. And maybe I'll also give you a copy of the syllabus. You might need that. Yeah. Nice. So, what other flavor of interval? Sometimes you want to just talk about everything starting at some threshold and going on forever. So, we'll talk about those. Those will be the so-called unbounded intervals. If you want the interval from A to the symbol infinity, well, what is that? That's just all numbers x. Let's call them x values. Greater than or equal to A. And of course that can be written as an inequality, as just all x values bigger than or equal to A. That seem fair enough? Nice. How does it change if I replace that bracket with a parentheses?
It's just greater than.
Just greater than. I want to exclude x, so let's just exclude x. And if you want from negative infinity to some input, I guess that's either x less than or equal to A, or x value is strictly less than A. Folks feel pretty okay? So you'll notice that like none of those have any brackets at infinity. And maybe here's just a little caution worth writing. Switch colors. I will never talk about things like 2 to infinity with a bracket at infinity. And there's a reason for that. That infinity right now is just a strictly formal symbol. It makes sense in the context of intervals, but it's not really a number. You can't really talk about infinity minus 5, or infinity minus infinity without deciding exactly what you mean. And one way of making sense of that is in language that's developed in calculus called limits. But in the context of intervals, we just want to talk about infinity as a number, so it can't be an infinity. So you'll never see a bracket at infinity because you'll never include it. It's not a number. That caution makes sense? There are fields of mathematics in which you would talk about infinity as something that you would include in an interval, but you'd have to decide what it actually means. Nice. Let's talk about absolute values. And maybe I'll start by you already know what absolute value means. There'll be something technical looking at the bottom of the page, but you already know what absolute value means. So let's just start with that. What's the absolute value of 5? 5, right? It's how big is 5? Well, 5 is 5 big. What's the absolute value of negative 5?
5.
Also 5, right? How big is negative 5? Well, it's 5 big. Its distance to 0 is 5. Now you think of that as the distance on the number line between that number and 0. So if there's 0, there's negative 5. Yeah, that distance is 5. Absolute value of negative pi.
Delicious.
Yeah, okay, good enough. Depends on the pi. And let's move on to just like mildly more involved things. What if I asked you something like the absolute value of 3 minus 6?
Then it's just the absolute value of -3.
Yeah, so you look, whenever you see a complicated expression, you evaluate things that are on the inside first. 3 minus 6 is -3. Now apply the absolute value. That gives you 3. Similarly, what's the absolute value of 6 minus 3 instead?
3.
Also 3. So there's like principle at play here. If I have two numbers subtracted inside an absolute value, do you think it matters which one is subtracted from the other? No. So that's nice. You can do a reverse order of some things in absolute value. 0. What's the absolute value of 0? 0. All right. So there's enough, I hope, to convince you that you remember what absolute value means, at least in the most explicit sense. What we're going to try to do in the next couple lines is motivate a more algebraic-looking formula for absolute value. So let's start with this. If I give you a positive number, if I tell you that x is a positive number, then what's its absolute value?
That number.
It's that number again. So if the number's name is x, it's x. When x is positive, the absolute value of x is x. Let's suppose I give you a negative number. Then like absolute value, like it wants to take the negative number and turn it into a positive. What's like an algebraic thing you can do that turns negatives into positives? Yeah. Multiply by -1. People agree? So here's one way of thinking about absolute value. If you give absolute value a positive number, absolute value doesn't do anything. It gives you that same number back. If you give absolute value a negative number, then absolute value gives you negative that same number. And there are like 3 flavors of numbers, right? There are positive numbers, negative numbers, and what's the number that's neither positive nor negative? 0. So if I'm going to write down just a case-wise definition, I better have all of my cases covered. What's the absolute value of 0? 0. I guess that's explicitly right there. So when x is 0, absolute value of x is 0. And those are all the types of numbers. So if you have something in an absolute value and you want to decide,
Bottom right one, you said the absolute value of x when it's less than 0 is negative x.
Let's just check that it walks. What's absolute value of -5?
5.
What's negative? -5.
5.
They agree? Yeah. So sorry, maybe I didn't actually let you finish the question you wanted to ask.
No, I'm just confused.
Okay. Yeah, so the idea is,
I thought you couldn't end with a negative off an absolute value.
ooh, but if x is negative, then negative x is positive. Just like if you have -5, you get 5. So if this x is already negative, then negative x becomes positive. And maybe this is worth, I think this is slightly out of order in the context of the class.
So are you saying if you have the absolute value of a negative number, you multiply it by -1?
Yeah.
Oh,
Yeah, that's all that says.
okay.
If x is negative, absolute value of x is negative x, or if you like, -1 times x, if you prefer. And I guess, I don't know, how many people are happier with writing down -1 times x in that context instead? Yeah, but do you agree that -1 times x is the same as negative x? Yeah, so tomato, potato in some sense. But like negative x is fewer symbols to write down. That's why I wrote that one. Groovy. So, on this line is a full formal definition of absolute value of x, in that if you have absolutely any number, you just need to decide which category that number falls into. That tells you how to compute absolute value. And this is just for the sake of introducing the notation. Whenever you have a situation where you have some function, it's got some formulas, and depending on what flavor of number you plug into it, you use different formulas. That's a thing called a piecewise function. And a piecewise formula is formatted as follows. If you want the absolute value of x, then when x is positive, well, according to this line, when x is positive, what's the absolute value of x? X. So, when x is positive, absolute value of x is x. When x is 0, what's the absolute value of x? When x is negative? Negative x. So whenever you see something in an absolute value, if you can decide whether the thing inside that absolute value is positive or negative, you can use this formula and write down that expression with no absolute values anymore. And that description is fancier than it needs to be. I think it'll feel very explicit if we just do some examples. Let's use exactly those ideas to evaluate this. Let's evaluate the absolute value of 5 minus the absolute value of 1 minus 7. And let's just walk it from the inside out. What's the expression you see there that's the most inside? That's inside the most things?
1 minus 7.
The 1 minus 7. So this might be like more steps than you would do in a write-up normally, but let's write down everything. What is 1 minus 7?
Negative 6.
Negative 6. So this is now, let's underline the step where something is happening. This is now the absolute value of 5 minus absolute value negative 6. Cool. All right. And let's just keep on going. Absolute value of negative 6?
6.
6. So, and again, this might be more steps than you would write out normally. That's the same as absolute value of 5 minus 6, which is
Negative 1.
which is
1.
cool. So there's a really explicit one. And notice, maybe we didn't need to refer to this formal definition at all. Let's try to walk something maybe slightly more abstract looking. Let's try to compute absolute value of pi minus 4. And I don't want to get like an expression with like some decimal approximation. I just want an expression without absolute value bars. So, in order to do that, let's ask this question. The thing inside the absolute value bar, that pi minus 4, is it positive, negative, or 0? Is pi minus 4 equal to 0? Cool. Okay, so that means we should not consider this line.
Well, it's negative, isn't it?
I hear on it's negative. Convince me why.
Because pi is 3.14, and 3 minus 4 would give you a negative 1.
Awesome. So pi is 3-ish. 3-ish minus 4 is negative? Cool. So the thing inside the absolute value bar, it's less than 0. Pi minus 4 is less than 0. So the thing inside the absolute value is negative. So which of the lines in this piecewise formula should I use? Yeah,
Negative x.
negative x, the bottom one. Yeah. Pi minus 4 is negative? Well, in this case. So pi minus 4 is negative pi minus 4. People agree? Should we simplify that at all? I mean, this is really like an open-ended, would you want to simplify it? How many people would want to simplify that if that was like the answer they got? Cool. How would you simplify it?
I put the negative on the pi and make it a positive in front of the 4.
Yeah, you can distribute the negative. And I guess as long as you're going to do that, maybe 4 minus pi looks nicer than that, and addition commutes. Of course, this didn't say anything about make sure to simplify your answer, did it? So I'd probably be happy with any of those. Folks feel pretty all right? Let's do one last thing with this example. And this is just to build up a habit. It's easy to make like silly mistakes when you're doing things quickly, and we definitely didn't do this quickly. I think we did this almost painfully slowly. But let's just think, if you had this answer and you like had skin in the game, you cared if this answer were correct. What's something you could do to just check if it's correct? You have access to any tool you would have at home.
Type it on the calculator.
Yeah, let's resort to a calculator. Can we ask the calculator what the absolute value of pi minus 4 is? A calculator that I will use often in this class is, no, don't sign in, the Google calculator. Absolute pi minus 4 seems to be about 0.85. Let's compare that with 4 minus pi. They agree? Neato. So, a thing to remember, you can double check any of your answers. Think about how to. Nice. All right, so, you know what? Here's a similar one for you. Square root of 5 minus 3. All that in absolute value. Only the 5's under the square root. Express that without any absolute value varies. And you would like to like talk to each other if you want. Maybe at least like compare your answers once you got them. Cool. What do we get?
About 1.
Yeah, but what's like the exact value you got?
Oh. I don't know, I didn't type it out or anything.
We'll come back to it.
Pretty sure the answer is negative, because rad 5 is less than -3.
Yeah, so
Or 3, rad 5 is less than
yeah, so that means that root 5 minus 3 is negative. Cool. So what will absolute value do to it? Well, this means the thing inside the absolute value is already negative. The piecewise formula instruction says whenever you see a negative number and you want its absolute value, stick an extra negative sign in front. So let's stick that extra negative sign in front. I agree that the answer is probably 1-ish. Let's maybe emphasize the negative with a color change. So root 5 minus 3 in absolute value is negative, the thing inside the absolute values. Folks feel good so far? Nice. And I guess we have the same question. Should we simplify? Should I spend time simplifying? Yeah. So I agree, it's about 1-ish, because root 5 is like 2-ish. I struggled with how big is root 5. Should I talk about that? Okay. Let's do that. So, whenever you see a square root, especially if it's not of a gigantic number, you can get at least an idea of how big it is without resorting to a machine. And here's a way to think about it. So, what's the square root function? The square root function wants you to give me a number whose square root is 5. What are some numbers reasonably close to 5 whose square roots you know?
2. Also
Yeah.
4.
Yeah, root 4 is 2. 4 is a little bit less than 5. So that'll be less than root 5. So root 5 is probably not much bigger than 2. Is there, what's the next perfect square after 5? 9. So root 5 should be no bigger than the square root of 9, known as 3. So root 5 has to be somewhere between 2 and 3, it's 2 point something. And looks like it's probably closer to 2 than 3. So there's like, if you like the simplest way of approximating a function at an input that it's hard to walk with. Take an input nearby that you do know how to walk with. There's an approximation. It's not a good approximation, but it's good enough for some applications. Groovy. Nice. All right, so absolute value is given by the distance between a number and 0. And here's a reason that that's important. If you want to measure the distance between any two numbers, it's given by absolute value. If you want the distance between two numbers x and y, it's the absolute value of the difference. Does that seem like a sane thing to call the distance between two numbers? And maybe like, here's a reasonable sanity check. Let's just draw -3 on the number line and 2 on the number line. Forget about that formula. If you just saw those two dots on this number line, what's the distance between them? 5, right? There's 1, 2, 3, 4, 5. The distance sure seems to be 5 units. On the other hand, let's also use the formula. So I guess that'll be absolute value of -3 minus 2. Is that 5? Awesome. Yeah, -3 minus 2, yeah, that's -5. Put the absolute value in place, gives you 5. Neato. So, let's just use this formula and do some translation. So, let's just write down a fact. The distance between 2 and 4 is equal to 2. So I guess without doing anything, do you agree that that appears to be true? Let's translate this into an equation using the distance formula. What's the formula for the distance from 2 to 4?
You have the value of 2 minus 4.
Awesome. So what does this really say? This says absolute value of 2 minus 4 is equal to 2. And is that true? Cool. Let's go slightly more abstract. Let's suppose I don't tell you what both of these numbers are. Let's suppose I tell you the distance between 0 and y is at least 5. So let's try to walk with that. What's the formula for the distance between 0 and y? Yeah,
It is just 0 minus 1.
almost.
Absolute 0 minus 1.
There we go. I don't like, I'm sure I'll make that exact error an awful lot because it's really easy to say, oh yeah, it's like 3 minus 6 when you add the absolute value of 3 minus 6. So there is the distance between 0 and y is at least 5. What does that mean?
Greater than or equal to?
Yeah. Is at least is a synonym for is greater than or equal to. And you know what? So there's like a literal translation. That look like something that you should simplify if you wanted to do something with it? Yeah, what does absolute value of 0 minus y simplify to? Yeah, just say that. Almost. There's one thing you're missing. The absolute value? Yeah. Yeah, right. Absolute value doesn't care if there's a negative inside of it. The whole point of absolute value is it erases a negative, so that negative in front of the y doesn't actually matter. But the absolute value bars still do. Cool. So the last thing I want to do in this particular section before we move on to the stuff that's actually on the calendar for today, you'll find that happens an awful lot in this class. I talk about the thing I was supposed to be doing yesterday, and we're about halfway done with the period. And eventually, once I get a full day behind, I'll update the calendar. That's life. Schedules are meant to be broken, right? So, let's talk about one last thing. Let's talk about solving equations that involve absolute value pairs. So let's suppose I ask you to solve this equation. Absolute value of x is equal to 4. So let's just think philosophically about what that means. That means that I want all of the inputs for x which result in absolute value equal to 4. So let's just see if we can list them. What are all the numbers that have absolute value equal to 4?
4, negative 4.
And here are 4 and a negative 4. Right? Because what's absolute value going to do? It's just going to forget the negative sign. So the input should be 4, except it might be negative. So there are two x values that have absolute value equal to 4. It's plus or minus 4. In fact, could that 4 basically have been anything? No. What would be bad if it want a particular something? Yeah. Yeah, negatives would be weird. But like, there's one general fact that comes out of this. If you have absolute value of some stuff is equal to a number, and that number is bigger than 0, then you can reduce this equation involving absolute value to no absolute value, and you introduce a plus or minus sign. The weird thing that can happen is negatives. So let's suppose instead you saw an equation like absolute value of x equal to negative 4. Is absolute value ever equal to negative 4? No, the whole point of absolute value is you always make the output positive. So does that equation have any solutions? Cool. I don't know if that needs an exclamation mark at the end, but there's one there. What about 0? What if I asked you to solve absolute value of x equals 0? What numbers are there whose absolute value is 0? Yeah, just 0? But if x were positive, like positive 0.356, then absolute value would be 0.356, which isn't 0. If it were negative 17, then absolute value of negative 17 is 17, isn't 0. Yeah, so the only thing left is 0. So, if you see absolute value of some stuff equals 0 in an equation, you can replace that with just that stuff and the absolute value has to be equal to 0. So let's use this process to solve a more complicated equation. Let's try to solve this. Absolute value x plus 5 minus 7 equals 3. And whenever you want to solve an equation, the goal is like get x on its own, right? But how do you do that? Well, you try to undo the last thing you do in that equation on the side with the x's and move it to the other side. So let's just go through that. There's the equation you want to solve. All the x's are on one side, and there's only one x. It looks like that minus 7 is the last thing you do. How do you undo minus 7? Add 7. So let's add 7 to both sides. Let's add 7 to both sides, and what does that turn that equation into?
Absolute value of x plus 5 equals 10.
Neato. Folks feel good? All right. The next thing I see is absolute value of some stuff is equal to 10. So I want to get rid of that absolute value. So that will become, instead of absolute value of stuff equals 10, it'll be stuff equals 10 or minus 10. So let's write that out. The equation you have is now absolute value of x plus 5 equals 10, which is positive. What numbers have absolute value equal to 10?
5 and negative 15.
Ah, you've gotten an answer to the whole question as opposed to the individual step I asked.
Oh.
Nope. So you're perfect. I've tried to break things down into very small steps. Let's just literally answer this question.
My bad.
What numbers have absolute value equal to 10? 10 and negative 10. So that means that absolute value of x, so since absolute value of x plus 5 is 10, that means x plus 5 is either 10 or x plus 5 is negative 10. Which now I think is going to end in the number you just told me, right? My memory is very short, but I assume it's the same numbers as you just told me. Cool. So I now see two separate equations. Do they both look like simpler equations than I had at the beginning? That's progress. Let's just solve both of these equations and we'll be done. Those look like easy equations to solve? Yeah, solve them. I think that's what you wind up with. So let's vary this a little bit. Here's a very similar problem. Let's try to solve this one. Let's just change that minus 7 to a plus 7 and see what happens. So I think I want to be quiet for just a few moments. Solve for me absolute value, x plus 5 plus 7 equals 3. Gesundheit. All right, so I think I'm not going to ask you what the answer is now. How many people have settled down on what the solution to this problem is? How many people got that there exist solutions? Cool. Nice, then let's talk through it. Maybe I'll start with this. So what is the solution to this problem?
No solution.
I hear there are no solutions. Anyone disagree? Cool. Should we talk through the process? Excellent. So folks are feeling pretty happy. So we have now covered the ideas relevant for the homework that was assigned Monday. That's why I pushed back the deadline. How many people had already just done these? In light of what we did, does anyone who has already made a submission think they want to revise their submission? You're allowed to. I'll only ever see the most recent submission. I'll see that there are previous submissions and I can look at them, but I'll only grade the most recent submission. If you ever Because right, if you're like me, you do your best proofreading after you hit submit on whatever electronic form you're using. So maybe you like say, yeah, I'm done with this problem, here it is. And then you like start really reading it because you've turned it in. If you realize you screwed something up, just like fix it. And then hit submit again. Cool. All right, and maybe it's worth pointing out the first of a great many extra credits is now available. The deadline to do the extra credits is the end of the semester, but I think for most people the end of the semester is busier than the beginning. So if you find you have some time, this is I think one of the lighter extra credits to do. Take a look at it on your own time. Let's do some geometry. Oh, and I don't think I asked this question yet. Has anyone accessed the WebWalk homework at this point? Okay, good. And you could? There weren't any like weird technological issues that stopped you? Excellent, cool. If you haven't yet, try to. If there are any issues, you should, get them fixed. Even if you don't plan on like doing the WebWalk tonight, if you have like 2 minutes, get into Canvas, click the right buttons to get into WebWalk. All right, let's do some geometry. So, right now we know how to do geometry on the line. We have a sense of inequality, so we know like what's to the left and right of a point. We know how to measure distance between points. That's about all the geometry you can do on a line. Let's start doing analytic geometry on the plane, and we will use this idea, which is attributed, at least in the European math history, to the mathematician René Descartes, who is also the same Descartes who's like the I think therefore I am Descartes. Of course, this idea really predates anything. I'm going to draw points on the plane and I'm going to give them coordinates. People were making maps before Descartes, so this idea isn't exclusive. It's not so clear whether the history is ever correct in names given to things. But they're called Cartesian coordinates. Let's use them. So let's just talk about Cartesian coordinates. So here's the idea. Draw a number line. Indicate the point that's 0. Now, perpendicular to that 0, draw another number line. That point where they cross is specified as the origin of the plane, and is just indicated with the coordinate 0, 0. So far so good, and hopefully feels very familiar. We'll coordinatize the whole plane, and the way we'll do it is, well, if I give you a pair of numbers, 5, 3, the standard convention is start at 0, 0, travel 5 units to the right. So there's the result of traveling 5 units to the right. Call that point 5, 0. Now go up by 3. And hopefully that's not like a surprising idea to anyone. Because that's like the same way as coordinates are drawn like on a map. You fix some point as the 0, 0 point, and then you say how far east and west to go and how far north and south to go. That's all this is. So for example, do you think you could label the point? Yeah.
Sorry, just noticed that the second point is up by 1 at the end of the sentence. Instead of up by 2.
Oh, yeah, that sounds like a typo I'd make. Thank you for catching that. In a perfect world, I will find time immediately after class to update the PDF. That won't change your paper copies, but it will change the online copies because that's how paper works. Neato. So let's talk about how to find that point. If I asked you to find the point -4, 2, do you think you could? Yeah, draw it. I think it's like, well, oh, maybe I'll draw a few candidates. Switch colors. Ooh, multiple choice. A, B, C, or D. -4, 2 could be which of those 4 orange points? Yeah. I hear an A. People agree? Yeah, good. The negative means you're going to go to the left. 1, 2, 3, 4. And then you'll go up 2. So this is -4, comma, +2. Cool. So here's the thing you'll just have to be aware of. That looks like the same notation as we use for open intervals, doesn't it? So sometimes in certain contexts, and the book will do this sometimes, it'll refer to the point at -4, 2 when it wants to specify that it's a point. I usually won't, I'll just use the notation -4, 2, and you'll just have to be aware of context, whether I mean the interval or the coordinate in space. Once we have these axes drawn, this breaks the plane up into 4 quadrants, and we label them as follows. There's quadrant 1, quadrant 2, quadrant 3, quadrant 4, and let's specify them. So notice in quadrant 1, the 2 coordinates of any point, which I'll often call the x and y coordinates. Well, if you have to go to the right and go up, x and y have to both be positive. Otherwise, you either go left or down. So quadrant 1 is specified by x's and y's both positive. What about quadrant 2?
Negative x's plus the
Quadrant 3?
negative.
Both negative. Quadrant 4?
Positive x and negative y.
Nice. And maybe we'll just like do maybe 2 quick sanity checks. 2, -3. What quadrant should that be in? I hear a quadrant 4. People agree? And if we draw it, yeah, there's 1, 2, 1, 2, 3 down because it's negative. Yeah, quadrant 4. And let's just be silly. -1, 0. What quadrant would you say that's in? I hear a call for quadrant 2. And let's just check. Yeah, it looks like the x value is negative. Is the y value positive? Yeah, so I think it's not quite in quadrant 2. Is this actually a trick question that I just asked? Like a super unfair one? So, what quadrant is that in?
It's on the x-axis.
It's on the x-axis. It's not in a quadrant at all. Is on, and let's maybe be super specific, is on the negative x-axis. Is not in a quadrant at all. Because right, if you wanted to say it's in quadrant 2, it's just as fair to say it's in quadrant 3. I don't want the answer to be both, I'd rather it be neither. Neato. Folks feeling good? Let's talk about measuring distances. So, here's the goal. Let's talk about how to measure the distance between 2 points in a plane. We'll get a formula for it. But first, let's just decide what the idea is. If you want the distance between this point, 2, 3, and -1, 1, that just means you want the length of that line segment, right? Fair enough. And maybe there's an idea here that I haven't said explicitly yet. If you want to draw that triangle, I guess we'll decide what that point should be. That's a right triangle? Distances, there's a nice formula for distances when you see a right triangle, right? What formula is this that I'm alluding to? Yeah.
The slope.
Slope will come up on the next page. But slope doesn't quite measure a distance. Yeah, the Pythagorean theorem is what I'm going for here. Slope will be super relevant on the next page, which I probably won't get to in 3 minutes. But hold on to that idea. So, let's think about the Pythagorean formula. Let's do it off to the side. And I don't know, maybe sometimes you'll see this called the Pythagorean theorem instead. I'll use the words interchangeably. A formula, right, it's like an equation that should be satisfied. A theorem is like a fact that's always true. So in this case, it is kind of both. So let's see what this says. So if this is a right triangle, and let's label the sides with some things, A, B, and C, then the Pythagorean formula is a formula. What formula does it say? Nice. And that's hopefully not like a fact that's new to people. There's a fact from geometry. Let's use that here. Could we determine the length of the base of this triangle? Yeah, how big is it? 3. And I don't know, how could you get that 3?
The absolute value of the x coordinates, the difference of the coordinates.
Awesome. So either in this case you could like count it. It's like 3 units. Or the formula is it is the absolute value of the difference between the x coordinates. So 2 minus 1. What about the height of this triangle? Height is 2. And I guess the answer to how would you compute the height is like the same, but y values instead? Cool. Is that enough to now compute the length of the diagonal? It's not diagonal, hypotenuse, length of the hypotenuse. Use the right one. So what does the Pythagorean formula say? Well, the distance squared should now be 3 squared plus 2 squared. And I don't know, like, I don't think it's worth harping on the fact that that results in 13. Well, it does. So if the square of the distance is 13, what is the distance? Awesome, root 13. That distance is equal to the square root of 13. Neato. Was there anything special about the actual coordinates used in this triangle? Could you follow it in general? If you did it in general, do you think we'd get like a formula we could use? I don't yet have time to write it, but we will. Oh, you could right now. Nice. So I'll stop there because I'm at time. We will see you tomorrow. Unless you're planning on coming by my office hour. I have an office hour today at 1, I think.
Hi, so let's move to the extra graph.
Cool.
I'll make copy for it.
Right now. Okay. I think this is, can you make my office hour today?
What is it? Again? Oh, sorry. Just look at the sheet.
No. I mean, I'm looking to remind myself because I don't know my office hours. Their time is when I know I'll be there. 1 o'clock today.
Sure, maybe I could.
Were you asking about this too?
Oh,
Or were you
because
just
you just
talking?
gotta do the explain.
Did you do the one that I don't give you space to really do in detail?
Yeah.
As an
Okay.
resolution.
Yeah, the solution.
Cool.
See you.
I expect my office hour will be pretty available today, so you'll be able to present that.
I was talking to my assistant advisor,
Mhm.
and she said it should have gotten sent out to you, combinations, testing and stuff. But one of my professors didn't get it for some other reason, so.
Yeah, you want, let's give a quick look at this. Boston's secondary class, yeah, I'll put my name in there. Yeah. Sorry, what I'm doing right now is just looking for how the notification. Okay. Are you in a rush to get to another place?
Who's the kid
Okay.
that at work? Actually, this kid we talked to, he had like the dark hair and like a really quiet voice.
Yeah, I finished one.
He was in our lecture.
No,
I don't know, maybe.
He was in our last lecture, he's just like, hey.
Got my.
Maybe he has some
That's okay.
Deanna Walton. That's you, right? Okay. Yeah, does this look like the right accommodation? Time and a half, reduced to distraction testing with electronics. Oh, and you're allowed to use medication, so even though I said like I don't like this, that doesn't apply to you. Low distraction fidget, and you're allowed to use it. Okay, cool. Have you been using it?
Usually my math class
Okay. Okay, yeah.
It's not as like election.
I also do the quality, so if you do want to rewatch it.
Yeah. Foundation for international students, you mentioned.
Yeah. Yeah.
I saw it online. I don't know how it works. I did like the class.
Academic skills and department related is let me pull up real quick where to go. I think I can stop the recording.